File System Interface. A file system serves as the organizational framework for storing and accessing data on a storage device in computing. It defines the structure for data storage, enabling the identification and retrieval of individual pieces of data. Without a file system, data stored on a medium would form an undifferentiated mass, lacking the organization necessary for effective utilization. A file system is a crucial component of computer storage, ensuring files remain accessible even after a user logs off. Each file possesses a name and specific access permissions, enabling controlled sharing among users. Additionally, files can be organized in various arrangements or complex structures to illustrate their relationships, enhancing system efficiency and user convenience. File attributes are crucial elements within an operating system, encompassing several key aspects. These attributes include the name of the file, serving as the sole information stored in a human-readable format, alongside an identifier that uniquely tags each file within the file system. Additionally, attributes such as location, pointing to the file's specific location on the device, and type, necessary for systems accommodating various file types, are vital. Size denotes the current file size, while protection attributes dictate access rights for reading, writing, and executing the file. Finally, attributes encompassing time, date, and security play pivotal roles in ensuring file protection, security, and monitoring within the system. File type refers to the operating system's capability to distinguish between various kinds of files such as text, binary, and source files. Operating systems like MS-DOS and UNIX categorize files into different types, including character special files, which handle data character by character such as mice and printers, ordinary files, which store user information enabling operations like addition, deletion, and modification, directory files serving as folders for organizing multiple files, and special files representing physical devices like printers, disks, and flash drives. File access methods are essential processes dictating how files are accessed and loaded into memory within an operating system. Typically, operating systems support a primary access method, though some accommodate multiple methods. The three primary file access methods are sequential access, direct random access, and index sequential access. Sequential access involves reading files sequentially from start to end. Direct random access allows for direct retrieval of data from any point in the file, and index sequential access utilizes an index to facilitate efficient retrieval of data based on specified criteria. Sequential access involves accessing records in a predetermined order within a file. Each record is processed individually in the sequence it appears in the file. This method is commonly used by compilers for file access. Random access, also known as direct random access, is a method that enables direct access to records. Each record is assigned its own address, facilitating direct reading and writing operations. Access methods for files can be categorized into sequential access and direct access. In sequential access, operations involve reading the next item, writing the next item, resetting the position, and no reading after the last write. On the other hand, direct access pertains to fixed-length logical records within a file. File operations encompass a range of actions including creation, writing, reading, repositioning within the file, deletion, opening to retrieve content from disk to memory, and closing to save changes made in memory back to the disk directory structure. These operations allow manipulation and management of files efficiently, facilitating tasks such as data storage, retrieval, and modification within a computer system. A directory structure is a hierarchical arrangement of nodes that store information about all files within a system. Each node represents a directory or file, forming a structured collection of data for easy navigation and organization. Typical file system organization involves structuring files and directories in a hierarchical manner for efficient storage and retrieval. Directory operations encompass various tasks such as searching for files, creating and deleting files, listing directory contents, and renaming files. These operations are fundamental for managing and organizing files within a directory system, facilitating efficient access and manipulation of data. Facilitating organization and accessibility of data. The directory organization is structured with efficiency and user convenience in mind. It facilitates swift file location, ensures user-friendly naming, allows multiple files with the same name for different users, and permits files to have various names. Additionally, it promotes logical grouping based on properties, such as categorizing files by type, e.g., Java programs, games, for easier management and access. A single-level directory system employs a solitary directory for all users, posing challenges with naming and grouping. With all users sharing one directory, there's a risk of naming conflicts, making it difficult to uniquely identify files. Additionally, organizing files based on user groups becomes problematic, as there's no hierarchical structure to segregate data effectively. The two-level directory system organizes files with a separate directory assigned to each user, facilitating efficient searching through the use of path names. This structure allows multiple users to have files with the same name without conflict. However, it lacks grouping capabilities, which might limit organizational options within the system. A tree-structured directory diagram illustrates the hierarchical organization of directories and files within a computer system. Tree-structured directories offer efficient searching and grouping capabilities, with the ability to navigate through directories using absolute or relative path names. Users can easily manage files and directories within the current working directory, creating new files or subdirectories with simple commands like mkdir for directories and room for file deletion. However, it's important to note that deleting a directory at the root level results in the removal of its entire subtree. For instance, deleting the directory, mail, would also delete all its subdirectories and files. File system mounting is the essential process through which an operating system enables access to files and directories stored on a storage device via the computer's file system. Before accessing a file system, it must be mounted. This involves associating it with a specific mount point within the existing file system structure. Unmounted file systems are essentially disconnected and need to be mounted at a designated mount point to become accessible to users. File sharing is a versatile computer service enabling multiple users to access the same files, often implemented through protection schemes. It's particularly beneficial on multi-user systems, where sharing enhances collaboration and efficiency. In distributed systems, files can be shared across networks, with the Network File System (NFS) standing out as a prevalent method for distributed file sharing. In multi-user systems, file sharing is managed through user IDs, which uniquely identify users and enable permissions and protections to be applied on a per-user basis. Group IDs facilitate group organization, allowing users to belong to specific groups and granting them group access rights. Each file or directory has an owner and can also be assigned to a specific group, providing granular control over access and management within the system. File protection is a crucial aspect, giving owners or creators control over actions and permissions within their files. They dictate what can be done and by whom, encompassing various types of access such as read, write, execute, append, delete, and list. These permissions ensure the integrity and confidentiality of the files, safeguarding against unauthorized access or modifications. Access control in Unix, Linux systems involves managing three classes of users: owners, groups, and the public, each with distinct levels of access permissions denoted by read, R, write, W, and execute, X. Owners have full access, 7, groups have moderate access, 6, and the public has limited access, 1. To enhance access control, managers can create unique groups and add users to them, then define specific access permissions for files or directories, ensuring appropriate levels of access for each entity. In Windows 7, access control lists, ACLs, are a fundamental aspect of security management. ACLs determine who can access a particular resource and what actions they can perform on it. A sample Unix directory listing displays various details about files and directories within a particular directory. It typically includes the file or directory name, permissions, indicating read, write, and execute access for owners, groups, and others, ownership, user and group, file size, and modification date. Thank you for watching.